To see how a splice is made, you'll see in this animation that the roll on the right is the running or printing roll, and the roll on the left is the roll readied for splicing and stationary. Above the two rolls is a festoon, which contains about 80 feet of paper, give or take, depending upon the type of press and speed. The festoon consists of several rollers and holds enough paper to feed the press during the splice since the new roll is not running. This festoon system allows the new roll to come up to speed. Once a splice is ready to be made, the festoon begins feeding paper to the press. The splice is made, the old web cut, and the new running roll is accelerated up to press speed, allowing the festoon to start storing paper for the next splice. You now can see an actual splice being made as the operator would see it. The running roll is near completion. And the splice is made.
Okay, we've looked at the ink unit and we've looked at the printing unit, but we haven't looked at the dampening unit yet. Okay, what's the dampening? I'm sure you've heard the term fountain solution during this program. So what fountain solution is we need something to keep those non-image areas of the plate clean. And what we do is we use a fountain. Now this fountain basically is water mixed with some chemistry. Now this chemistry contains a material called a desensitizing agent. And that could be gum arabic or something like that. Gum has been used for years. There are derivatives today that are also used. This material is effective when it's acidified. That means it works best on the metal when it's in a pH range of around 3.2 to 5.8, and that depends on the manufacturer and the type of material he's using. And what the printer will do is take a gallon of water and mix maybe 3, 4, 5, 6 ounces of this etch, if you will, that contains this desensitizing agent to a gallon of water. Now obviously I'm standing in front of a very large system. Unlike sheet fed that runs out of small units and feeds each individual printing unit, most big web printers feed out of a main central system, mix this material automatically. So unlike sheet fed where the press crew might take a gallon, mix it up, pour it in, this is done automatically. They can set the amount of ounces per gallon they need and it's all pumped in manually. So behind here someplace I'll have a storage of the fountain etch and bring in water that's been deionized, maybe treated for hardness and things like that. Now there's two things the press crew is going to look at. One of them is pH, one of them is conductivity. What's pH and what's conductivity? Well, in the olden days, this gum arabic typically worked when it's acidified, and as materials from the paper or the ink bled into the system, it changed the pH. So as the pH rose, the material didn't work as effectively anymore in keeping the non-image areas of the plate clean. So, but what the pressman had to do is monitor that. What the manufacturers have done today is added what's called buffering agents. They can keep that pH under control, even though some materials come in like calcium carbonate or clay or things like that. So what's carbonate, or what's conductivity? Well, conductivity is measurement of contamination. Contamination coming into the system. Now that doesn't necessarily have to come from paper. It can come from ink. It can come from something falling from the ceiling. But nevertheless, if something comes in, it raises this conductivity level. Think of you working on your car. You have a wire. You take a conductivity meter and you plug the two ends of that meter to that wire, and the conductivity goes way up. It says the wire is okay. We're doing the same thing only on a milliohm basis, on a very smaller scale. So as the press crew makes this material up from scratch, they've added 6 ounces of the etch to a gallon of water. In this case, so many ounces to so many gallons, and this may be about 50 gallons. And that's obviously more than 6 ounces. They're going to be 6 times to make up 50. What they're going to do is that conductivity may start off at 1800, let's say, milliohms, but over the course of a day it rises to 2800 milliohms. Usually when it gets over 1000 over the normal, we start looking for problems. Now that doesn't mean we got problems with the paper. That means that something's going on. Something's coming into the system to contaminate it. And when it gets contaminated, it's not as effective as keeping the non-image areas clean. So that's one of the things the printer is going to look for, pH and conductivity. And you can see we can keep that, we can measure that pH and conductivity automatically. And what the press crew can do with this particular system is during the day, come over and chart and read it off the system and tell us what their pH is and what their conductivity is. That way they monitor and they know what's happening with their system at all times. This is another area of process control for the crew. Unlike your cold set webs, the 17, 18-inch variety, which are a lot slower than a heat set web, they run around 900 to 1,000 feet per minute. They can run out of a 5-pound can of ink, much like sheet fed printers do. But the large webs, the 25 to 35 to 57-inch variety, have a high demand for ink. How are they going to do that? Well, they're going to use what's called a tote bin. They're going to have a tote bin for each color. These tote bins range around 2,600 pounds each. So if you have a 4-color press, you've got a tote bin for black, a tote bin for cyan, which is a form of blue, a tote bin for magenta, which is a form of red, and a tote bin for yellow, the 4 primary process colors. Now let's say we got a 6-color web. How do we do that? We want to run 2 special shades, what is known as a PMS or a Pantone matching color. Those might run out of what's called a kit. That's a 5-gallon bucket that the press crew will manually scoop the ink out of and put in the fountain. Now these totes are going to operate by pumps. At the press unit, you're going to have a sonar or a sonic or some sort of leveling device that monitors how much ink is in the fountain itself. When the level goes down, the sensor sends a signal to the pump, it pumps ink in. When the level comes up, the pump is shut off. So it's manually controlled, and the crew can adjust that level that they want.